Welcome back. So there is a bit more syntax to try and accept that I just wanted to highlight. We've seen the top two, but we can also add in an else and a finally, and neither of these have to be there. But let me just show you how it works. If you can remember way back when we were doing the guessing game, we were asking a user for input, and then we tried to convert that number or whatever they typed in to an int. But if the user didn't type in an int, for example, if they just typed nothing and we tried to turn that into an int, that causes an error. So what we could do is use a try and accept to prevent that. So we could do something like try, and then we'll just do input, please enter a number, and then save that to a variable. Let's call it num equals, and then let's turn it into an int like this. So we'll try to ask them for an input and then turn it into an int. So this shouldn't cause any problems, but the conversion to an int might. So if we encounter a problem, for now I'll just leave it as accept. Let's just start by printing that's not a number, something like that. Okay, so on its own, if we run this right now, Python 3, please enter a number. If I type 10, we're all good. But if I type A, it tells me that's not a number. So already this could help us with that guessing game, just adding a try and accept instead of our code breaking when we try and convert input or whatever the user types to an int, we now could handle it. What would we actually want to do? Well, we would probably have this in a loop and then repeat the loop. But for now, I'll come back to that. I just want to show else and finally. So if we put else in here and we put some code, I'm in the else, and I run this again. Let me clear my terminal, make some more room. So if I type 9, I get I'm in the else. If I type ASD, I don't. So what this shows us is that else will run when accept does not. So try will run, and it's going to see if it works or if there's a problem. If there's a problem, accept will run. If there's not a problem, else will run. And that brings us to finally. And finally will run no matter what after this. So in here, I'll do a print, and we'll just write, runs no matter what. Okay? So now if we try one more time, if I enter a valid number like 12, we get the else and we get the finally. If I enter an invalid number just by hitting enter too soon, we get that's not a number, so that's from the accept, and then runs no matter what from the finally. Okay, so hopefully that's clear. Try will attempt to do something. If there's a problem, accept runs. If there's not a problem, else runs, and no matter what, finally runs. So most commonly used are try and accept, definitely, but you should know that these exist. And if I did want to make this, right now this runs one time, but for our guessing game example, we don't just want to give up on the user. If they enter something like S, and that's not a number, we should ask them again. So what we could do, I'll copy this and comment that part out, is something like this. While true, repeat this entire thing. But we don't want to just repeat it forever. It's an infinite loop. So when do we want to break out? Well, when this part runs. So instead of I'm in the else, let's say, good job, you entered a number. And then break. And that should stop the loop. And let's see what happens right now. So I'm going to run it again. Please enter a number. If I enter A, that's not a number. Please enter a number again. If I enter something like that. But as soon as I enter a number, good job, you entered a number. That's the else. So we break out. But it's important to know the finally still runs no matter what. But we're now out of the loop. So then down here, if I printed something like rest of game logic, I try it again. And this time I don't know, F, okay, and then I enter 8, that's my actual guess. Good job, you entered a number from the else, our finally runs, and then the code after the loop runs. Okay, so hopefully you can see how this is useful. Like I said, finally, It's not as commonly used in my experience, but this whole pattern, especially when you're dealing with user input and the tendency for users to get things wrong more than once, this is a common structure. Have a loop like this, while true, and then you break out if nothing went wrong. But if there's a problem, then the loop just runs again, and you give the user feedback to explain that's not a number or whatever the problem is. And a small improvement we could make, rather than accepting all errors here, what kind of error would cause, or what's the error we're really concerned about? It's a value error. So that would be when a user enters a string, which is the right type. So it's not a type error, but it needs to be a number string, if that makes sense. It needs to be a numeric string rather than a letter. So that's a value. And just double check it still works. So if I cause a problem, we get that's not a number, and that's coming because we are accepting value errors. Okay. So one more example I have for you. I'm going to make a new file called divide.py. And we're going to define a really simple function called divide. And this is still a silly example, but it's a little more involved. There's more than one type of error that we're going to accept. And let's say it takes two numbers like a and b. And the whole idea is that we would call it by something like this, 1, 2. All right, and that should return to us 0.5, very simple. But if I passed in something like 1 divided by 0, that causes an error. What about a divided by 2? So we're going to write some logic to check for those problems, okay? So first up, all that we're going to do is write try a divided by b, and we'll return that. And we can just put a one except in here, which is not a good idea for the most part if there's more than one error. But let's just print something went wrong. Okay, so let's try running print of divide 1, 2, and then the same thing with 1, 0. So we get 0.5, and then we get something went wrong, and we also get the none because we tried to print something and nothing came back, but don't worry about that. So it's working here, but all we're doing is saying something went wrong. And instead of doing that, we want to be very explicit. And I believe it's called zero division error. So instead, we'll accept only that error, and we'll print for now, don't divide by 0, please. And now if we run this, where'd you go? There it is. We get don't divide by 0, please. Okay, but that still doesn't handle everything, because if I try to do print 1 divided by a, and I run it now, we get type error, unsupported operand types. So let's just add another except for a type error. Just do it after the line, except type error. And then this time let's print a and b must be ints or floats, something like that. And now if we run it, we get a and b must be int or floats. So now we are accepting two different errors. And one change we could make, not to make this a better function really, but just to use an else, I'll save this to a variable called result, and then in the else, I will print a little f string. It says something like a divided by b is result, just so that we're doing something a bit different than just a traditional division that we wouldn't even need this for. Now if we test it out, we get 1 divided by 2 is 0.5, and then our second one is causing this error. One last thing to show you, if we actually want the error itself that is triggering this, we can add an as, so accept type error as, and I think most of the time I see ERR, and we can print ERR or do something with it like this. And so now if I cause a type error like I am here, let me just comment that one out. We get a and b must be ints or floats. We wrote that. And then we printed the error, which is unsupported operand types for division, int and string. So inside the official division function, the operator, there's a line that is raising a type error. And basically, this is what's being passed into that raise. And we can do the same thing for zero division error if we wanted to. And the other thing that we could do, I'll show you a second example, is combine the errors into a single line with a tuple. So do type error like that, and then I could get rid of this. But the thing is, then we kind of have to be more general about the problem, just say something went wrong, and we could do an as error and then print error afterwards. But we can't specifically write a message up here that says you divided by 0 or that was a type error, unless we could add an if statement and check, is error type error, or is error a zero division error? But I prefer just to catch individual errors separately. And now if we run it, we get something went wrong, unsupported operand types. And if we also divide it by 0, run the same code, we get the first little error, and then the second time something went wrong, division by 0. Okay, so the point of that was to show you that you can accept more than one error. You need a tuple using a single accept, but you could also just chain together multiple accepts if you are actually doing different things. So in this case, we're just printing, but we might want to call some other code only if we get a type error, versus if we get a zero division error, we want to print something. So you can use more than one accept, you can use a single one, and just use a tuple. Also, you can name the error, give it a name with as, and then refer to it inside of that accept. Alrighty, so that's pretty much it for try and except blocks. Next, I'm going to show you something called PDB, Python debugger, and you'll be able to step through your code one line at a time using PDB. See you then.